In this video, we are going to be looking at convergence of a geometric number pattern. Okay, so they say use two different methods to convert the recurring decimal 0.55555 to a proper fraction. Right. Remember, a proper fraction is basically a fraction that can be written as a over b, where the numerator is smaller than the denominator. Right, improper, the numerator is bigger than the denominator. Okay, so they want us to convert this to a over b, basically, using two methods. The first method we learned in approximately grade 8 or 9. So you always let x equals to 0.55555, and then you show three dots that this pattern will keep on going like that. Ne? I always just keep my numbers to 5, 6. Ne? Perfect. And then how many numbers are repeating? It's only one. It's a 5, right? So we're going to remove the decimal point once. Sharp. So to move the decimal point once, remember this is equation 1. So I'm going to take equation 1 and multiply by 10. Let's say there was 52525252. I would multiply by 100. Why? Because now there will be two numbers that are recurring. So you always multiply by, for example, if it's 1 recurring, you multiply by 10. 2 recurring, you multiply by 100. 3 recurring, you multiply by 1,000. By 3 recurring, I mean, let's say you had 523, 523, 523, and so on. Sharp. So this side, multiply by 10, you get 10x. And then this side, the decimal point will move here if you multiply that by 10. So you're going to have 5, 5, 5, 5, 5, 5. You always show the three dots that this is still recurring. And then this is equation number 2. Then you always say 2 minus 1. So 10x minus x gives you 9x, which is equals to, remember this recurring and that recurring will cancel. So here you have 5 minus 0 basically, which is just 5. Then you divide by 9 both sides. Then you have x equals to 5 over 9. And that gives you a very nice proper fraction. Right, that was the first method. The second method is going to be applying this. So you have 0.5 there. Right, I'm going to do method 2 here. Guys, we need to acknowledge that this can be written in this form. This can be 0.5 plus 0.05 plus 0.005 plus 0.0005 and so on. Right, the pattern can continue infinitely. Sharp. If you add this 2, you get 0.55. If you add this 3, you get 0.555 and so on and so on. Right. And then, guys, this we can see that it forms a geometric pattern. We can prove it. Let's check T2 over T1 and check T3 over T2. Yeah? Let's see what we get. Here I have 0.05 over 0.5. Here I have 0.005 all over 0.05. Ladies and gents, let's press that on a calculator and see what we get. So I have 0.05 over 0.5. That gives me 1 over 10. Right, let's check here. 0.005 over 0.05. That also gives us 1 over 10. Therefore, we can, because the question can say, show that this number here is a geometric pattern. You'll still use this method. Ne? You're going to say, therefore, geometric. Why? Because T2 over T1 is the same as T3 over T2, right? And then now we can see, guys, that this number here basically is 0.1, right? Which is our R, 0.1. Never round off. Ne? The reason why I just use in decimal is because it's easy and I don't have to round off, right? Sharp. You never round off in number patterns. Never ever round off. If you have to use a decimal that is rounded off, rather use this fraction part as your R. Remember, this is our constant ratio. And then, ladies and gentlemen, we can conclude that this is convergent, right? Convergent. Why? Because R is basically 0.1, which is in between this interval. Remember, for us to have convergent, we must be in this interval. Okay, ladies and gentlemen. And then from there, if we have convergent, I can see that, okay, this guy here is basically this and then that plus that plus that plus that to infinity. So I can do sum to infinity. You see, it's the sum to infinity. Therefore, since it's convergent, the sum to infinity will be a over 1 minus r, where our a is the first term, which is 0.5. So 0.5 is your first term over 1 minus r, which is 0.1. Let's press that on a calculator and see what we get. 0.5 over 1 minus 0.1. That gives us the same answer of 5 over 9. And we have shown that 0.5 recurringly can be written as 5 over 9. And that's it for this question, ladies and gentlemen. Aluta continua. Tango.